Today we're going to discuss an explosive topic. What happens during a nuclear explosion? Hey, my name is Elina, I'm your friendly nuclear physicist, and I bet you always wondered what happens during a nuclear explosion and how does the bomb actually explode. We're going to break down this video into 3 topics. We're going first to discuss what happens inside the bomb itself. Secondly, what are the effects to the environment, and thirdly, the effects to the human body. Starting off with the first topic, and that is what happens inside the nuclear bomb and how it is designed to be able to explode. We're going to go into a detail and I'm going to try to explain to you exactly what happens. There's different types of nuclear bombs. In the one we're going to discuss today, it is called thermonuclear, or you might have heard of the term hydrogen bombs. These bombs combine 2 physical phenomena, and that is fission and fusion. To explain it simply, fission is when we have big atoms that are split in the middle by an incoming small particle such as neutron, and because of this splitting, energy is released. And fusion, it's quite the opposite, when we have small atoms that are combined together, and because of this recombination, energy is released to the environment. In a thermonuclear bomb, fission is the first reaction that is initiated. Fission is actually the reaction that is used inside a nuclear reactor. But here, the purpose of the reaction is to actually get out of control. So how it happens is that there is a neutron source, a source that produces small particles that travel fast inside the bomb, that actually initiates the fission reaction, which means it splits the big atoms of uranium or plutonium inside the bomb, and that releases energy. In a classical nuclear bomb, this would be the blast, and this would be the reason why the explosion would have been created, and then we would go to the fallout. In a thermonuclear bomb, there is a second sequence of events that happens after the fission, and that is that the energy that is released from fission is triggering the fusion reaction. And what that means is that the fission energy is fusing hydrogen inside the bomb. So the smaller particles now are combining together, releasing an even bigger amount of energy, and these reactions are chain reactions, which means that the moment they start, they produce even more particles, such as neutrons, that they, of course, generate even more reaction, and in this case we have fission producing neutrons, generating fusion, which produces other particles generating fission and fusion, and that is how the reaction basically becomes out of control. And when it becomes out of control, this is when we have the explosion. This creates a big fireball and the typical mushroom that we have seen in pictures of a nuclear explosion, and that is because some of the material inside the fireball evaporates and creating the shape that we see, spreading itself into the atmosphere and eventually starting to fall out on the ground. Moving on to the second topic, and that is what is the effect on the environment after a nuclear explosion happens. The effect begins with the nuclear fallout. This is when the particles of the mushroom have started falling down on the ground and contaminate everything that they touch. That can be either soil, that can be water that used to be potable, that can be, for example, clothing or anything that it is on their way. It is also important to notice that animals can also be contaminated by radioactivity that falls down from the sky, and that is why if there is stray dogs or stray cats that are outside the street and during a nuclear explosion that are nearby the location are usually removed or at least getting tested for contamination. Now, during the nuclear fallout, the particles fall down in a very, very small dust form. And this dust can easily travel with the wind. So for example, even if a nuclear explosion happens in a location, that does not necessarily mean that it will be contained in that location. If the wind blows into a certain direction, then radioactive dust can travel with it and actually contaminate a very large area to the extent of several countries or even the whole continent. And this is what makes a nuclear bomb different, contrary, for example, to a missile, is the fact that it can affect a very big area of land or people as well, whereas a missile is a more targeted kind of explosion. And moving on to our third part, and this is a discussion about the human body and how people are affected from a nuclear blast, and that is really depending on the distance you are from the blast when it happens, and also the explosion itself, how big the bomb initially was. So people that are within 2 kilometers radius of the explosion are most probably going to instantly die, And that is mostly because of the explosion itself and the blast, and not so much because of the radioactivity. However, people that are further away actually might get contaminated if they are outside at the time of the explosion, and depending on the type of contamination, if it is external or if it is internal by inhaling contaminated air, for example, different effects can happen to their body. If one is externally contaminated by radiation, things such as redness on the skin, which is sort of mild, up to acute radiation sickness, which is very severe, can happen, and people can survive if they were further away and only some mild rash appeared on their body. And also there are severe cases that people can die even if they were further away because the amount of contamination they received was very high. Now, when it comes to the internal contamination, things are a little bit different, and that can happen, for example, if one drinks contaminated water, eats contaminated food, or even inhales contaminated air. What happens is that you are inhaling, or I don't want to say you. What happens in that case is that radioactive particles are ingested inside one's body, and they are radioactive and spread radioactivity from within. That means that one's organs are exposed completely to the radioactivity and are actually not protected by any barrier such as your skin or clothing, which makes the situation very severe. In this case, of course, depending on how much dose a person received internally, probably a person will not die immediately because of this kind of condition, but definitely the cells inside one's body become cancerous, and there is a very high chance of developing cancer later on in one's life. How much later on depends on the dose they received. If one received higher dose, a cancer can happen within a couple of years. If one received a lower dose, then in a further stage in their lifetime. And this is one of the very interesting reasons that one cannot really associate radioactivity with cancer, because there are so many ways one can have cancer from, and that is why it is really hard to pinpoint that the cancer ones developed is exactly because they were exposed to radioactivity. And here's an interesting fact. This is how the former Soviet Union actually presented a very small number of casualties and people who were affected by the Chernobyl accident. It is because it was very hard to scientifically associate cancer or health diseases with the radiation that people received. So even though it does make logical sense, it is really hard to prove when it comes to science. That is why it was sort of easy to show the fact that the people who were in Ukraine or in the immediate areas were not severely affected by the situation. And this is what happens during a nuclear explosion, what happens to the bomb itself and how it explodes, how it affects the environment and the people who are around it. Thanks for watching this video. Please don't forget to like and subscribe. Also, leave a comment down below of what are your thoughts about this video, as well as future video ideas you would like me to make. It's been Elina, your friendly nuclear physicist, and until next time, see you soon. How do I say it easily? I want to say that it's like in your organs, you know.